In this video, I'll very briefly go over effect size in the independent samples t-test. The good news is you're going to see it's very similar to the effect size calculations you've done previously. So in this section, we're going to talk about Cohens D, but I'm also going to introduce you to something called R-squared. So the Cohens D effect size, the formula will look very familiar. In the case of the numerator, we're looking at the mean differences between the two groups. So we're looking at the mean of group 1 minus the mean of group 2. That's going to give us our numerator in our effect size formula. For a denominator, we've been doing the standard deviation. We've been using the standard deviation. And now what we're using is the pooled standard deviation. So how do we get the pooled standard deviation? We've only done the pooled variance. But what we can do to variance is find the square root of it to find standard deviation. So you'll take your pooled variance that you figured for your t statistic, and you'll take the square root of that to get the pooled standard deviation. So I've plugged the numbers in for this study that we have been talking about. And if you take the mean of 93 minus the mean of 85, divided by the square root of the pooled variance, which gives us the pooled standard deviation of 4.47, that gives us an effect size of 1.79. That's a very large effect. And you might be looking at this number and thinking, hey, wait a minute, this is more than 1. Can this be possible? Yes, Cohens D can be more than 1. It's not actually very likely, but it can be more than 1. And so this Cohens D shows a very large effect size, meaning that the difference between these two groups is substantial. There's another way to talk about effect size, and that's by using something called R-squared. R-squared is just a formula that says how much of the variability in scores is explained by the treatment effect. So there's variability in the scores of mean 1 and mean 2. How much of that can we say was really because of children's programming, and then the rest of it can be explained by something else perhaps? So we use R-squared to figure this out. And what we do is we take the variability accounted for by that difference divided by the total variability. And so basically this is taking your t-score squared divided by your t-scored squared plus your degrees of freedom. It's just a way of putting together these numbers, and we end up with an effect size that can be interpreted as this. We ended up with 0.47, so 47% of the variability in scores is explained by watching children's programming. And we haven't really talked about how do you interpret that. Is 47% a lot? And I will give you the spoiler alert. Yes, it is a lot. So your textbook talks a little bit more about R-squared. I just wanted to introduce it to you. It's not something that I'm going to be testing you on, but it is just another way of looking at effect size. All right, in the last video, we're going to put it all together.